Hello everybody, how you doing? This is Mr. Dowse. In this video I'm going to try and go over 17 through 22. This is the third video going over the Unit 7 review that you'll be taking here shortly. So if we look here at 17, 18, and 19, it says mark on the figures the measurements for the missing segments and sides. So we're focusing just on the segments in here. The next three problems deal with angles. We'll get to those here in a little bit. But let's look here. 17 is saying we have FGHJ, this is a rectangle, and it wants us to find these 6 segments. So what do we know about rectangles first and foremost? There's a couple things, right? It has all the properties of a parallelogram, but it also has these two additional properties here. And if we are looking at sides and segments, let's look at a couple here. Let's look at diagonals. Diagonals are segments. It says diagonals bisect each other. And there's another set of segments here. It says opposite sides are parallel, opposite sides are congruent. So that's important. And then if we look at rectangles, it says all angles are right angles. We're not looking at angles. And it says diagonals are congruent. So if we look here, the main thing we need to look at is diagonals bisect each other, opposite sides are congruent, and also diagonals are congruent. So look at this picture here. We know opposite sides must be congruent because that's the definition of a parallelogram. So if G is 5, so is GH. And or if J is 5, so is GH. And then if JH is 12, so must FG. So that's opposite sides are congruent. We also know that diagonals bisect each other. So this one's going to equal this one, and this one's going to equal this one. So if this is 6.5, so is this one. But then this last property, this is unique to rectangles. It says diagonals are congruent. So if this is 6.5 and so is this one, well then this one is going to be 6.5 and so is this one. So we know that all these are actually going to be congruent. So if this whole diagonal is 13, this whole diagonal should be 13 as well. And since this is being cut in half by this diagonal, then this is going to be 6.5 and 6.5. So I haven't actually gone through what we're trying to find here. I just know that opposite sides are equal. We know that diagonals bisect each other and that diagonals must be equal to each other. And so that's how we get all these 6.5s here. So look at FG, that happens to be 12 because opposite sides are equal. GH is 5 because again opposite sides are equal. JM is 6.5 because diagonals bisect each other. GJ, if you add those up, is 13. And since I know again that this is a rectangle, the diagonals are going to be congruent to each other. So if JG is 13, so is FH. And then we're cutting these in half to get these smaller segments. So FM is going to be half of 13, which is 6.5. But from F to H, that whole thing must be 13 because, again, diagonals are congruent on rectangles. 18 talks about rhombuses. So rhombuses, and again, rhombuses here specifically, we're talking about segments and like diagonals and sides here. So I'm going to focus specifically on properties that deal with sides and diagonals. So a rhombus is a parallelogram, so we know opposite sides are congruent. We also know that diagonals bisect each other. Those are important. But if I look at a rhombus says all sides are congruent, and then beyond that, everything else deals with angles. So we know opposite sides are congruent, diagonals bisect each other, but all sides are congruent. So not just opposite sides are congruent, it's all sides are congruent. So on this picture here, if we have a rhombus, if AB is 17, all these other sides must be 17 because that's the definition of a rhombus. All sides are congruent. But again, we also have the property that diagonals bisect each other. So I know that AM is congruent to MC because DB is bisecting that diagonal. And then we know that if DM is 15, like this segment must equal this segment because this diagonal AC is cutting diagonal DB into 2 equal parts. So if AM is 8, so is MC. If DM is 15, so should MB. So there's like a little symmetry going on here. So CD is 17. We know that AC is, if I add 8 and 8, is 16. MC, from M to C, is 8. BD, B to D, if I take 15 and 15, that gives me 30. Also BM is 15. And then AD is 17 because, again, all sides are going to be congruent. And I mentioned something here that I probably should have mentioned on rectangles. Rectangles, rhombuses, and squares have lines of symmetry. For a rhombus, the lines of symmetry are down the diagonals. So this is a line of symmetry. So notice the left half and right half kind of are identical. And so if you look at this other diagonal as well, this is another line of symmetry. Notice how the left half and right half from this line to the left and to the line to the right are symmetric. But a rectangle, the lines of symmetry are down the middle of the sides. So the left and right side balance out. Down the middle of the sides, if I turn it sideways, you can see the left and right half here are also symmetric. So the lines of symmetry are down the middle of the sides on a rectangle, but they're down the diagonals on a rhombus. Another problem we have here is a square. So, squares, let's see here. Square is a combination of a rectangle and a rhombus. It has all the properties of a parallelogram, plus the properties of a rectangle, plus the properties of a rhombus. So if we look here, not only are opposite sides going to be congruent, but all sides are congruent. So if one side is 17, all sides are going to be 17. Not only that, it says diagonals bisect each other, but beyond them being bisecting each other, it says diagonals are congruent. So I'm combining the properties of all of these shapes. So if this diagonal RT would cut US in half, and vice versa, US is cutting segment RT in half, so if MT is 12, so is RM, but since this also has the properties of a rectangle, the diagonal RT is congruent to diagonal UM. So if RT is 24, so is US. And if US is being bisected by UT, then this would be 12, and so would this one. So squares are perfectly symmetrical no matter how you look at them. They're symmetrical down the sides, so the left half and right half is symmetrical, or across here, so the top half and the bottom half are symmetrical. Or if you look at the diagonals, the left side of the shape and the right side, based on the diagonal here, would be symmetrical. Or this line RT, this diagonal is another line of symmetry. The left and right half are symmetric. So it's a combination of the rectangles, which have lines of symmetry down the sides, and the rhombus, which have lines of symmetry down the diagonals. Square has all four of those. So a long way of saying RU is going to be 17 because all the sides are going to be congruent. MS is 12 because diagonals bisect each other, but they're also congruent on a square. RT is going to be 24. If I add the 12 and 12, I get a 24. And then U2 is also going to be 17, again, because all sides are congruent. I think I'm actually going to stop this video here because it's getting a little long, and I'll do another video for 20 through 22. So have a good day. Bye-bye.